A major financial company recently automated the workload of 700 full-time agents using a single AI system. On paper, it was a total success. Yet, shortly after reaching peak automation, that same company began aggressively rehiring human staff. In early 2024, the Swedish fintech firm Klarna deployed an open AI-powered assistant. Within its first month, the system handled 2.3 million conversations in 35 different languages, a volume equivalent to the processing power of those 700 human agents. The immediate financial metrics were impressive. Average resolution times dropped from 11 minutes to under 2, leading the firm to project a $40 million improvement to its annual profits. But by mid-2025, the strategy hit a wall. CEO Sebastian Siemiatkowski acknowledged that prioritizing raw cost reduction over the quality of the conversation had actively degraded the customer experience. The company eventually shifted toward a human-AI hybrid model, recognizing that the insurance and finance industries require a level of nuance and empathy the machine couldn't replicate. Klarna's pivot highlights a specific risk in the automation wave. Efficiency gains can create a vacuum in human judgment that corporations eventually have to fill at a higher cost. This shift at the corporate level mirrors a divergence happening across the entire global economy. AI is generating massive new wealth through productivity, but that wealth is concentrating within a small group of tech giants and their shareholders. We are facing a choice in how this technology is deployed. Will these gains reach the broader workforce, or are we engineering a new class of displaced workers? The historical record provides a clear precedent for this dynamic. In the 19th century, a machine-driven boom froze wage growth for an entire generation. In 1790 Britain, the first industrial revolution was gaining momentum, fueled by the revolutionary power of the steam engine. While national wealth and corporate profits surged during this period, real wages for the working class remained stagnant for 50 years. This divergence became known as Engels' pause. Friedrich Engels was among the first to document this deterioration of living standards, observing that massive increases in economic output were not reaching the people operating the machines. The cause was a feedback loop of capital. Factory owners reinvested their massive profits back into more machines and infrastructure, rather than increasing the pay of their workers. History shows that technological progress is not a rising tide that lifts everyone automatically. It is a series of decisions about where that new wealth is diverted. Today, the data center has replaced the steam engine as the engine of economic divergence, concentrating power in the hands of those who own the new industrial infrastructure. This era is defined by skill compression. Research shows that AI assistants increase average productivity by 14%, but those gains are lopsided. Novice workers see a 34% improvement, while experienced professionals see almost no change, rapidly narrowing the gap between junior and senior staff. This compression is a direct threat to India's IT sector. Millions of junior coders and support staff are vulnerable as global clients use AI to automate the routine tasks that once required massive offshore teams. The Indian government has responded with initiatives like the Viksit Bharat mission, attempting to retrain the workforce and steer the transition through national industrial policy. We are at risk of a white-collar Engels pause. Corporate output is climbing, but for the middle-class knowledge worker, wages and job security are beginning to flatten. The lesson from Klarna is that machines are efficient at data, but so at the human elements of service. High-value work still requires a human in the loop to manage complexity. Systems designed for augmentation keep humans in charge. Rather than replacing the person, the AI provides real-time tips and data, allowing a single operator to handle a much broader range of complex questions. This data suggests that augmentation actually improves the work experience. AI tools are linked to lower attrition rates, particularly for the least experienced workers who use the technology to move down the learning curve faster. AI proves most effective when used as a cognitive bridge, helping entry-level staff reach expert performance levels in a fraction of the usual time. If AI development follows the path of least resistance, it will default to higher inequality and extreme industrial concentration. A different future requires policies that actively encourage open-source access and prioritize labor complementing innovations over simple replacement. The 50-year stagnation of the 1800s was an accident of history. Today, allowing AI to repeat that pattern would be a deliberate consequence of our current policy decisions. We spent decades imagining talking machines as a distant laboratory experiment. But in less than 2 years, generative models transitioned from research curiosities to a standard daily tool for millions of people. The internet took 7 years to reach its first 100 million users. ChatGPT reached that same milestone in 2 months. Global businesses are now integrating these systems into their primary workflows because the software can serve 1 million customers with the same marginal cost as serving 100. It allows a single programmer or researcher to execute tasks that previously required a full team. This is the fastest diffusing technology ever recorded. It is currently rewriting the baseline speed for industrial and creative output. But those algorithms require a massive physical footprint. They live inside global data centers that never sleep, demanding a constant, stable flow of electricity that some reports suggest will consume 12% of total U.S. energy production by 2028. The raw horsepower of this era is compute. It is generated by specialized graphics processing units, silicon chips designed specifically to handle the trillions of calculations required for machine learning. A small group of companies, including Microsoft, Google, and NVIDIA, are spending billions of dollars to build out this physical architecture. Controlling this hardware allows these firms to dictate the pace of discovery. They are birthing new algorithms and specialized startups on a weekly basis, creating a closed loop of innovation. We are watching a global race to monopolize the infrastructure that will host the next century's productivity gains. The focus of this technology has shifted. It is moving from assisting humans to substituting for them in high-level cognitive tasks. In many workplaces, a single employee using these tools can now handle the resolution of customer issues, writing of code, or drafting of reports that used to sustain an entire department. This creates a direct incentive for corporate operations to scale down their human workforce while maintaining or even increasing their total output. The math is efficient. 20 highly leveraged workers can produce what 100 once did, effectively displacing the other 80 from the production cycle. If a fraction of the people can do all the work, we have to ask what becomes of the remaining workforce. We are moving toward a future where national wealth and corporate profits climb, even as the number of available jobs for the middle class shrinks. Technology drives productivity, but history shows that productivity doesn't always lead to broad prosperity. The critical factor is who captures the value. Since the late 90s, corporate profit margins have roughly doubled, while labor's share of the total economy has declined by nearly 10 percentage points. That widening gap shows that a robust economy and record profits can coexist with stagnant wages for the average worker. Economists warn of the Turing trap, the tendency to design technology that mimics human labor to reduce costs, rather than augmenting humans to create entirely new goods and services. If these tools are used only to replace payroll, the gains of the AI era will concentrate among a small group of shareholders and executives, leaving the median worker behind. This pattern isn't new. Humanity experienced a nearly identical economic shock 2 centuries ago. During the British Industrial Revolution, the steam engine and mechanized production promised to lift living standards by generating extraordinary gains in national wealth. Between 1790 and 1840, Britain's per capita GDP grew by 46%. But for the people operating these looms, the reality was very different. The factories that made Britain the wealthiest nation on earth simultaneously impoverished the people working in them. Real wages for the working class grew by only 12% over that same 50-year window. This historical precedent suggests that technological revolutions do not automatically distribute wealth. Left to market forces alone, they consolidate it. Friedrich Engels documented this 50-year period of soaring productivity and stagnant wages. Today, economists call this phenomenon Engels' pause. The modern parallels are striking. In the 1800s, machines replaced skilled weavers. Today, algorithms are targeting stable, middle-class knowledge jobs. If AI automates white-collar work faster than we can create new industries to replace those roles, we are entering a modern Engels pause. We are facing a 200-year-old economic trap. To avoid a generation of wage stagnation, we have to look past the productivity headlines and understand how the Industrial Revolution actually broke the workforce. For most of human history, economic output had a hard physical limit. If you wanted to harvest a field, weave a textile, or build a road, you relied almost entirely on human and animal muscle. The Industrial Revolution broke that physical limit. The introduction of steam engines and mechanized factories allowed economies to produce goods at a scale that muscle power alone could never achieve. At the time, the public assumption was straightforward. If machines allowed society to produce more goods in less time, then the people doing the work would naturally become wealthier. The historical data tells a different story. Between 1790 and 1840, British GDP grew by nearly 50% as factory output surged, yet the real wages of the working class rose by just 12%. For half a century, the average worker saw almost no financial benefit from the new machines. This exposes a recurring economic illusion, the belief that creating massive technological wealth automatically guarantees better pay for the workforce. The social theorist Friedrich Engels was among the first to document this economic disconnect in the 1840s. This graph illustrates the 50-year period now known as Engels' pause. The top line shows per capita GDP and output skyrocketing. The bottom line tracks wages, remaining flat. As we add a third line tracking corporate profits, we see it matches the surge in GDP. The financial gains accrued directly to the owners of capital, the factory proprietors and patent holders. Meanwhile, an influx of cheap labor stripped workers of their bargaining power. In rapidly expanding urban centers, the low wages led to overcrowded slums, poor sanitation, and a severe deterioration of basic living standards. The mechanized factories that elevated Britain into the wealthiest nation on earth were simultaneously impoverishing the specific generation of people who operated them. Engels' pause did eventually end. After 1840, capital accumulation caught up with the new technologies. Labor laws improved, education spread, and wages finally began rising in tandem with industrial output. The economy settled into a shared growth pattern that lasted over a century, until the late 20th century, when digital technologies began rewriting the rules of labor again. The internet and software boom rewarded scale. A digital platform could serve 1 million customers with the same effort required to serve 100. This shifted value creation away from large human payrolls and toward intangible digital assets. We can see the results of this shift in this chart. Since the late 1990s, corporate profit margins have roughly doubled. Over that exact same period, labor's share of the national GDP has declined by nearly 10 percentage points. Economic headlines often highlight robust GDP growth and low unemployment, but job quantity obscures the broader trend. The actual share of national wealth is slowly shifting away from the workforce. Now, the global labor markets are facing their next major, unpredictable technological shock, the rapid rise of artificial intelligence. When the internet arrived, it took roughly 2 decades to fully permeate the economy and alter the workforce, giving businesses and employees time to adapt. This chart compares the adoption speed of the two technologies. It took the internet 7 years to reach 100 million users. ChatGPT reached that same milestone in just 2 months. This velocity presents an immediate economic danger. AI is integrating into corporate workflows faster than labor markets can create replacement occupations or retrain displaced workers. Without the luxury of time to absorb the shock, the modern workforce is highly vulnerable to a new, hyper-accelerated Engels pause. The Industrial Revolution targeted manual labor and physical muscle. Generative AI is explicitly designed to perform cognitive, white-collar work. Economists point to a systemic flaw in how the tech industry approaches this transition, calling it the Turing trap. It is an intense, narrow focus on building machines that perfectly mimic human labor. When technology is engineered specifically as a substitute for a human worker, it acts as a direct competitor. That dynamic drives down wages and strips cognitive workers of their negotiating power. The alternative is augmentation. Instead of using technology to replace human effort, it can be designed to complement it, giving workers tools that allow them to solve highly complex, entirely new problems that didn't exist before. The choice between engineering a direct substitute or an augmenting tool will determine whether the resulting wealth concentrates at the top or spreads throughout the workforce. We are currently at an intersection. AI will either trigger a second Engels pause, or it will elevate the broader economy. In the bear case scenario, AI serves merely to automate stable middle-class knowledge jobs. Corporate margins expand while median wages stagnate, and global wealth concentrates within a handful of hyperscale tech monopolies. The alternative relies on open source, widely accessible AI. Used as an augmenting tool, it elevates the productivity of junior workers, sparks entirely new industries, and triggers a period of shared economic growth. Technology does not operate on a predetermined destiny. The outcome depends entirely on the design choices of tech corporations, the regulatory framework set by policymakers, and the adaptability of labor. But a modern Engels pause is the path of least resistance. Unless we design AI to augment human value, history is poised to repeat itself. If the global hierarchy is currently being rewritten by artificial intelligence, where exactly does a country of 1.4 billion people fit into the new map? On paper, India has a massive head start. It holds the world's largest youth demographic, a deeply established software engineering workforce, and a thriving startup ecosystem. It also possesses a proven technological advantage known as digital public infrastructure, or DPI. By building open, state-backed systems like Aadhaar for digital identity and UPI for instant payments, the country bypassed traditional stages of banking and telecom development. Look at this shop counter. Systems like UPI have achieved incredible grassroots penetration. The population adopts new technology at an unmatched scale, from rural street vendors to major urban corporations. With this digital foundation and rapid adoption rate, the nation is perfectly positioned to dominate the software layer of AI. But in the era of large language models, software alone is no longer enough. Frontier AI is strictly bound by the laws of physics. Code is only as powerful as the physical infrastructure that runs it. Training a modern model demands tens of thousands of high-performance GPUs, energy-intensive data centers to keep those processors cool, and billions of dollars in upfront capital expenditure. This chart shows private AI investment and global data center capacity, and it reveals a stark reality. While the United States and China have amassed massive hardware and investment monopolies, India faces a severe infrastructure deficit. Without domestic compute power, all of that top-tier engineering talent and population-scale data will ultimately be forced to run on foreign hardware. To address this hardware deficit directly, the government launched the $1.2 billion India AI mission. The core strategy is to build a publicly funded, sovereign AI compute backbone. Instead of leaving hardware access entirely to the private market, the state is stepping in to democratize the processing power. For academic researchers and local startups, the government is subsidizing GPU time for as low as 65 rupees an hour, ensuring they aren't priced out of the industry by foreign tech giants. This compute access is driving a shift in national focus. Rather than merely deploying imported Western models, Indian engineers are actively researching and building indigenous foundation models from scratch. The India AI mission functions as a targeted industrial policy. The objective is to build sovereign technological infrastructure and deliberately break long-term foreign dependencies. The ultimate application of this sovereign capability is solving the massive linguistic fragmentation of the subcontinent. By training foundational models on India's 22 official languages, non-English speaking populations can interact with the digital economy natively, using only their voice. In practice, this means rural farmers can ask a voice assistant for real-time weather and crop data in their local dialect, while public services can be delivered automatically across linguistic borders. By shifting the primary interface from text to native language voice, AI tools can start to bridge the digital divide for millions of Indians formerly excluded by language or literacy barriers. But if the country fails to build its own infrastructure and defaults to being a consumer market, it faces severe economic consequences. This diagram illustrates the mechanics of the consumer trap. When Indian businesses use foreign AI models running on foreign hardware, the data generated by Indian users flows outward, while a reciprocal stream of licensing fees siphons monetary value right out of the domestic economy. This contrasts sharply with the IT boom of the 1990s. Back then, the country captured wealth by exporting labor value to the world. Now, AI automation threatens to reverse that exact flow. Relying on imported AI guarantees that domestic users will generate the raw data, but foreign entities will capture the resulting wealth. This leaves the nation with a defining dilemma. Will it remain the world's largest consumer of artificial intelligence, or will it claim a seat as a creator of the AI future? The outcome hinges entirely on the infrastructure investments and policy choices being debated at forums like the India AI Impact Summit right now. In the 21st century, whoever controls the compute and the models ultimately controls their own economic future. In our final episode, we will analyze exactly how this global race will conclude and what it means for the rest of the world. Look at almost any headline about artificial intelligence, and you'll find a persistent anxiety, the fear that automated systems are coming for human jobs. Since the late 1990s, corporate profit margins have roughly doubled, while labor's share of national GDP has contracted by nearly 10 percentage points. As the internet era matured, economic value shifted away from payrolls and into the intangible assets, the software, data, and algorithms held by capital owners. Focusing on whether an algorithm can write an email or code a website misses the actual stakes. The real question is who gets to keep the trillions of dollars of wealth that algorithm generates. For 20 years, the software industry operated on a simple premise. A small team could write code, scale it, and reach millions of users with almost zero marginal cost. Frontier AI models require a massive physical footprint. Training the next generation of intelligence has become an industrial-scale engineering project. Training a leading foundation model requires tens of thousands of specialized GPUs, cooling systems that consume millions of gallons of water, and a power grid capable of handling the electricity load of a small city, all demanding billions of dollars in upfront capital. These extreme costs act as a financial moat. Independent developers are effectively locked out of building foundational intelligence from scratch. We have left the era of lightware software. We are now in a heady industrial resource race, where the only players on the field are a handful of corporations with the capital to buy the hardware. Look at this photograph. During the Industrial Revolution, the operator pulling the levers on the factory floor didn't accumulate the wealth. The power belonged to the people who owned the factory and the railroads that moved the goods. In the 21st century, compute, the raw processing power provided by GPUs, is the new factory. It is the crude oil of the modern economy. And owning that crude oil triggers a specific economic phenomenon. It creates an inescapable positive feedback loop. Companies that control the most compute can train the most capable models. Those superior capabilities naturally attract the vast majority of users, which in turn generates a massive influx of data. That user data and subscription revenue flows right back to the top. It swells the company's valuation, giving them the capital to buy even more compute, accelerating the entire cycle. By the time a competitor tries to enter the market, the leaders are already several laps ahead. This self-reinforcing flywheel explains why a few tech giants currently command multi-trillion-dollar valuations and hold a staggering grip on the global financial system. This creates a strange paradox for the rest of the economy. At the bottom, user productivity is exploding, even as the top becomes a pure infrastructure monopoly. Because of these models, the marginal cost of producing written content, analyzing data, or writing software has dropped to near zero. A startup consisting of 3 people can now execute marketing, operations, and coding tasks that would have historically required a payroll of 100 human employees. If you are an entrepreneur or a creator, your ability to build products and reach a market is greater right now than at any point in human history. But that surge in capability is deceptive. The fact that usage has been democratized perfectly masks a dangerous underlying reality. The ownership of the system is hyper-concentrated. There is a massive economic chasm between paying a monthly subscription to use a tool and owning the intellectual property and infrastructure that powers it. Every time a developer builds an application on top of an existing tech giant's API, they are making that giant's model smarter. Their hard work feeds directly back into the incumbent's flywheel. It is an echo of historical company towns. The workers were highly productive, but they were paid in company scrip that could only be spent at the owner's store, keeping them permanently trapped in the system. Over the next decade, artificial intelligence will generate trillions of dollars in new economic value. We have to decide if that wealth will flow to the people doing the work or to the entities that own the computing power. True economic sovereignty requires possessing the foundational infrastructure. If a society does not own the compute, they are simply renting their future. Which brings us directly to India's position in this global reallocation of wealth. India faces a distinct risk. With over 1 billion citizens, the country could easily settle into the role of the world's largest consumer market. In that scenario, Indian data and capital simply bleed outward to fuel foreign AI flywheels. Or, India can choose to be a builder. That means directing massive investments towards sovereign compute infrastructure and training domestic models on local datasets. Failing to build native AI infrastructure today carries the exact same weight as failing to build steel mills and factories during the Industrial Revolution. India's prosperity does not rely on adopting foreign software. It rests entirely on the decision to construct and own the factories of the 21st century. Artificial intelligence is the most decisive technology of the 21st century. As the global race accelerates, the immediate challenge for India is whether it has the physical track required to compete. On paper, the baseline foundation is massive. India holds the largest youth demographic, a thriving startup ecosystem, and millions of software engineers who have driven the global digital economy for decades. This engineering scale built the country's digital public infrastructure, or DPI. Systems like Aadhaar and UPI successfully connected a billion-plus population, bringing digital payments and identity straight to the neighborhood retail shop. The rules of tech supremacy, however, have evolved. Having a massive workforce of software developers is no longer sufficient to build cutting-edge artificial intelligence. Developing modern AI is an intensely physical, capital-heavy infrastructure challenge, and right now, India is operating at a severe disadvantage. The bottleneck comes down to compute, the hardware and processing power that trains AI models. Today, compute functions as the new global oil, demanding thousands of specialized GPUs, massive data centers, and enormous amounts of raw electricity. India generates 20% of global data, yet holds only 3% of data center capacity. Without domestic hardware, developers rent processing power from foreign tech giants, creating a continuous pipeline of capital flowing directly out of the country. Building this infrastructure locally presents severe logistical hurdles. It requires upgrading electrical grids, solving complex cooling bottlenecks, and expanding high-capacity data centers well beyond the major metropolitan hubs. Until India secures its own sovereign compute infrastructure, its legendary IT sector risks operating entirely as a downstream dependency of foreign hardware empires. To counter this dependency, the state is staging a massive intervention through the India AI Mission. It ranks among the largest state-backed tech programs ever launched globally. With a committed budget of 10,371 crore rupees, the mission aims to procure a national backbone of up to 50,000 high-performance GPUs. This hardware will be made accessible through heavy state subsidies. The government plans to provide compute access to local startups and researchers for as little as 65 rupees an hour, democratizing the tools needed for innovation. This domestic hardware will power uniquely Indian foundational models. Instead of relying on English-centric Western systems, these models are being trained natively on India's 22 official languages. The India AI Mission functions as a vital sovereign defense mechanism, ensuring the nation builds its own intelligence rather than renting it from abroad. India's distinct advantage lies in how it plans to deploy this AI. The strategy involves layering these domestic AI models directly on top of its existing population-scale digital public infrastructure. Initiatives like the Bashini platform use voice-to-voice AI to bypass traditional literacy and language barriers entirely, granting non-English speakers native access to digital services. This approach translates into practical, life-saving applications: predictive weather advisories for rural farmers, remote diagnostic support for healthcare workers, and highly personalized education tools. While Western markets primarily focus on optimizing enterprise efficiency, India is engineering AI to clear long-standing developmental bottlenecks in entirely untapped rural markets. India's true competitive edge lies in integrating intelligence into a billion-person network, ensuring that scale itself becomes a primary driver of social mobility and human productivity. The stakes of failure are devastating. Generative AI threatens the routine coding and support roles employing millions in India's IT sectors. Without a sovereign ecosystem, India functions as a data farm, harvesting local information, processing it overseas, and selling it back as proprietary services. Skilled AI elite would thrive, while the vast middle-tier workforce finds their routine jobs entirely automated. Treating artificial intelligence simply as another software tool to license and consume leads straight to digital colonization in the 21st century. The nation faces a stark binary choice: remain a passive consumer of foreign algorithms or become a sovereign creator of its own digital destiny. Achieving true independence requires monumental, immediate action. AI data centers, power grids, and domestic chip manufacturing must be built with the exact same urgency and capital previously reserved for highways and ports. It requires smart regulatory guardrails that protect citizen data without suffocating the researchers and startups trying to build the ecosystem. The window to act is narrow. Policy and investment decisions finalized right now will lock in India's global standing for decades to come. India already possesses the data, the scale, and the human genius. Now it must summon the capital and the infrastructure to write its own future. Artificial intelligence generates massive technological wealth, bringing with it a highly concentrated accumulation of digital and financial power. We have to consider whether a severe, insurmountable wealth gap is the unavoidable destiny of this technological era. Technology itself does not dictate human outcomes. To map where this current shift leads, we have to examine the specific mechanisms that governed previous eras of automation. The distribution of new wealth has always been determined by human choices, policies, and the institutions we build around the machines. During the first 50 years of the British Industrial Revolution, the introduction of mechanized manufacturing triggered a severe societal shock. The economic historian Robert C. Allen named this period Engels' pause, after Frederick Engels. From 1790 to 1840, British output per worker skyrocketed, while working-class wages remained flat. The profits accrued almost exclusively to the owners of the new physical capital. The stagnation lasted half a century. It broke only when capital accumulation caught up and society implemented structural adaptations, expanding public education, reforming labor laws, and creating new industries to absorb the workforce. The historical record demonstrates that economies can absorb massive technological displacement, but it requires deliberate, systemic evolution rather than passive observation. Transitioning toward a high-productivity future requires reevaluating our most basic social contracts, beginning with education. Educational models are shifting away from tasks that machines now perform better, like rote memorization or data processing, and moving toward the human-centric skills of problem-solving, creative synthesis, and collaborative oversight. These new skills require tools. Raw processing power, storage, and access to advanced models have become the foundational resources of the modern economy. If the physical infrastructure required to train and run these systems remains monopolized by a handful of centralized conglomerates, the resulting wealth gap will be mathematically difficult to close. This illustrates a model of democratized compute, where processing power is treated as a public utility. Instead of concentrating power in a single core, resources are distributed to a wider network of individual users. By ensuring high-performance servers are accessible to independent researchers, students, and small startups, these actors can generate their own data streams and innovate without a massive upfront capital investment. This distributed growth contrasts with a gate-kept model, where the centralized core chokes off the smaller nodes, restricting development to a select few and slowing the overall rate of innovation. Redefining literacy is ineffective if the population lacks the computational power required to act on those new ideas. Broad-based prosperity also depends on how we direct innovation. The goal is to create entirely new tasks and professions that restore demand for human labor, rather than simply automating existing jobs. India is currently moving from a consumer of global technology to a sovereign developer of its own digital ecosystem. This involves a proactive national strategy, like the India AI mission, which focuses on developing localized models and empowering a domestic startup ecosystem. This initiative targets the physical constraints of development, offering subsidized access to GPUs and expanding supercomputing platforms like Aerowatt to ensure researchers have domestic processing power. By building this digital public infrastructure, the country ensures that the economic value and intellectual property generated by AI are retained locally, supporting national growth. National conclaves like Viksit Bharat 2047 align industry leaders and government officials around this long-term development goal. Converting technological potential into equitable prosperity requires this level of sovereign planning and institutional coordination. We are navigating the tension between two likely outcomes, a future of mass task displacement and one of unprecedented job creation. With these systems already embedded in global workflows, the focus has shifted to the terms of our preparedness. Consider the recent instances of companies that dismissed their human workforces in favor of total automation, but found themselves hiring human teams back months later. They discovered that while AI can replicate patterns, it lacks the tacit knowledge and judgment required for non-routine problems. When humans use these tools to handle complex synthesis, while machines manage the formulaic tasks, the combined output exceeds what either could achieve alone. The wealth created in this era will ultimately belong to those who build, adapt, and choose to actively collaborate with these systems. The future remains firmly in human hands. Imagine a major corporation decides to fire and replace hundreds of its human customer service agents with a generative AI system. On paper, the logic is purely mathematical. Eliminate human overhead to maximize efficiency. In quarterly earnings calls, executives celebrate the immediate result. They report a sharp drop in operating costs and massive productivity gains, pitching the AI as a flawless engine for optimization. If this remains an isolated case, the impact is minimal. But as this same substitution logic scales across thousands of departments simultaneously, it begins to erode the routine cognitive work that supports the global middle class. India is uniquely exposed to this shift. Its $280 billion technology sector relies on a massive workforce to handle routine software maintenance and customer support, the exact tasks generative AI is engineered to automate. This current path of adoption threatens to wipe out the primary economic engine for millions of workers in developing nations. This obsession with creating machines that perfectly mimic human capability is known as the Turing trap. The trap lies in the design. By building software that acts as a direct substitute for labor, technologists are automating existing roles without creating new, high-value tasks for humans to perform. The macroeconomic result is a decoupling of wealth. As corporate productivity soars, the green line here, worker wages and labor demand stagnate, illustrated by the red line pulling away. This trajectory isn't a byproduct of the technology, it's a deliberate choice by the people building it. We have a historical blueprint for this phenomenon. During the first industrial revolution, Friedrich Engels documented a specific 50-year period of worker hardship. Between 1790 and 1840, Britain saw an explosion in output from steam engines and textile mills. Yet, working-class wages remained completely flat. The economic gains flowed exclusively to the owners of physical capital, the factory proprietors and patent holders, leaving labor with zero bargaining power. The AI rollout is following this same mechanical path, effectively entering a digital Engels pause. Without a shift in policy, the AI revolution will replicate this 19th century pattern of extreme wealth concentration and widespread worker impoverishment. Modern tax systems are accelerating this divide. Rather than remaining neutral, global tax codes frequently place a higher burden on human labor while offering steep incentives for automation. This data shows marginal effective tax rates across different assets. It is significantly cheaper to invest in software and hardware than to employ a person. In India and the United States, corporate tax structures have widened this gap, subsidizing the replacement of human workers. Physical infrastructure creates a second layer of concentration. The specialized hardware and massive data centers required to run AI are owned by a handful of global tech giants. This monopoly turns even proposed solutions, like universal basic compute, into a single point of failure. If access to the digital economy is tied to a centralized identity system, that access becomes an entitlement that can be gated or revoked by the entities managing the servers. There is a counter-philosophy to the Turing trap known as augmentation. Instead of designing machines to replace humans, augmentation builds AI as an interactive co-pilot that expands a person's capabilities. Purely automated systems are hitting a wall. Replacing humans entirely leads to a loss of the context, adaptability, and empathy required for complex problems. The most durable and profitable future lies in these human-AI hybrid models, where the machine enhances rather than erases the worker. Recall that corporation that fired its customer service agents to maximize efficiency. In many cases, companies were forced to rehire human staff to stabilize operations after raw automation failed to handle high-friction customer needs. The software could execute routine tasks perfectly, but it lacked the human judgment, creativity, and accountability needed to build trust with a customer. AI will still generate immense wealth and accelerate global productivity, but the lesson of the Industrial Revolution is that productivity gains do not automatically translate into broad-based prosperity. As we transition into this economy, the primary struggle shifts towards who actually owns the infrastructure and who captures the resulting wealth. If nothing changes, the default winners will be the current owners of AI systems, compute hardware, and existing tech monopolies. India has the capacity to actively architect this new economy, rather than just observing its rollout. The nation holds clear strategic advantages: a deep talent pool, a vibrant startup ecosystem, and a rapidly expanding footprint in data center infrastructure. The investment and policy choices made right now determine if the country remains a consumer of imported systems or a foundational builder of global infrastructure. Algorithms are tools, not destiny. The future of work is dictated by institutional ownership and human choice. The path we take isn't a fixed law of nature. It's the result of human policy and design choices made right now.